Hey everyone, I want to thank you for tuning in to one of EPARTRADE's Race Industry Now Tech webinars. If you're a part of the racing industry or you're just passionate about racing tech, don't forget to like this video and subscribe to our channel so you never miss a new episode.
Good morning and welcome to Race Industry Now, the weekly webinar series from EPARTRADE, presented to you by ERP, Performance Plus Global Logistics, Feria, Peak, Fifth Third Bank Motorsport, Quire, and CTEC Manufacturing. I am Francisque Savignan, the founder and CEO of EPARTRADE, the racing industry, every minute, every day. This is episode 562, and we're going to be talking coatings with Oerlikon. With me this morning are Julie Kin, the co-founder of EPARTRADE, and a wonderful host, Mr. Brad Gillie. Julie?
Thank you, Francis. It's hard to believe we are almost through this season of Race Industry Now. And if you've noticed on our newsletters, we started announcing our presenters for Race Industry Week, our 6th annual. So be sure to sign in, save your seat. You've never seen such a gathering of motorsports, the brightest people in motorsports. So sign in, Brad.
Yeah, I look forward to it. I know there are a lot of great names that are already on there that have been announced, and I know there are plenty more great ones to come as well. So we look forward to that, and we look forward to our presentation. Francis, Judy, we'll see you guys again here very shortly. And today's topic, driving performance forward. S3p expansion, DLC gearbox and engine solutions, shaping the future of performance coatings in global motorsport by Oerlikon. And our panelists today, Martin Hahn, Global Product Manager, Piston Group and Motorsports, Dr. Martin Bohley, Technical Business Development, Automotive PVD, and Dr. Emanuel Tack, Tribology Expert. Gentlemen, welcome. I hope y'all are doing well today.
Yes, thank you for the invitation. We are good. We are happy to be here, and I think it will be a very exciting webinar today. And yes, we prepared an awesome presentation with a lot of details for the crowd. And yeah, be excited and follow us here.
Well, that sounds great. Before we get started, Martin, I want to just remind folks that if you have a question at any point during the presentation here today, if you're watching us live, please feel free to type it into the chat. We definitely want to answer some questions that you have. But I know you three gentlemen do have an awesome presentation, and I really look forward to talking about the coatings. It's amazing the technology that you guys continue to bring, and welcome back. We're thrilled you're here again.
Thank you. Thank you. I will start sharing my screen.
All right, we can
fine.
see.
Can you see my screen?
Yeah, we can see that. That looks great.
Perfect. Thank you. Yes, as you mentioned, we are here for a special webinar from Oerlikon Balzers, and we have a lot of insights for you. And with me, I have my colleagues, Dr. Martin Bohley and Dr. Emanuel Tack. We have really prepared some special things for you. It will be interesting. And I will start directly with my first slides here. Oerlikon, top coater in motorsports. We talking today about thin film coatings, but we have a lot more. We have thick film coatings, what you may know from Sumibor for the cylinder liner technology. We have coatings for turbocharger, for example, and a lot of other stuff. And for example, additionally as well, AM with what we can provide, especially in US. Today we will have a special, not only, but a special talk again for the S3p technology. It's really an awesome developed high pumps or further developed high pumps technology, 100% by Balzers, Oerlikon Balzers. And the really interesting point on that technology is that we have the possibility here with our equipment to scale the pulse duration and the plasma density. That's a very important tool or screw at the process to be able to make tailor-made coatings for our customers. Of course, we have as well a portfolio where we can grab a special coating for certain needs on valves, for example, on piston pins and finger followers and all that stuff. But especially with that technology, if you have a really difficult problem, we can address that with our equipment technology and coating technology. What is the background of that S3p technology? We combined two basic technologies, the arc evaporation and the magnetron sputtering, and combined all the good things of these two technologies into one big one with a big effort of high ionization of the deposition flux and dense coatings, of course, good adhesion. That's also, let's say, a minimum requirement. And we have perfect smooth coatings with the S3p technology, which is with a really low roughness on the top of the coating. Here an example on a valve, and there you can see on the lower picture here in that area, that was with the arc evaporation, a lot of droplets. So we had to post-treat these parts to get a roughness which is useful for the use case in the engine at the end. And now we have virtually, you see it on the upper picture, no droplets anymore. And of course, there is still the possibility to get a post-treatment, but we have that high quality. You can see it on the right side on the pictures compared on that plate. Previously, arc evaporation to top of the S3p-based technology. There's no more droplet anymore. That's really, really amazing result. What is really exciting, what is the portfolio we can apply this S3p coatings? We have already a lot of experience with that. For example, on camshafts, on finger followers, on piston pins, on crankshafts, gears as well. You will hear something today about that. And it is, yes, a big step forward in the technology. And interesting is, where can you have the service at the end? We have on our Motorsports footprint map, a global footprint, and we increased that. We have an expansion here on the S3p technology as well. We started with that in Japan years ago already. We transferred over Europe. We have a new machine in Limoges in France, where is our Motorsports competence center based. In our development center, of course, in Liechtenstein, Switzerland, and we expand to USA with some marks. Looking forward to have it full running with beginning of next year. And yes, but there's also a new thing coming up. I can't talk too much about it, but it's really big. And only one small hint. Until now, we are limited on camshafts, for example, of 3 cylinders or V6 engines. But in future, we will get bigger. Let's take that, and the surprise will come in roughly 2 weeks. And there's a new launch, and stay tuned. Check out our website continuously, and then you will see what's coming next on that. And of course, get in touch with me on the PRI in December. Then we can discuss about that topics. May you have V10 or V12 or V8. cylinder race engine where you want to coat the camshaft. I'm there with my colleagues from US, and I'm happy to discuss your needs and your topics on the PRI review. And with that, I lead over to my colleague, Martin Bohley.
Thanks, Martin. I requested sharing, so I hope it's coming through.
Yeah, we'll get you set up with that. I'll let you know when we can see the screen, Martin.
Perfect.
There we go. Now it's starting to come up. Yeah, we can
Okay.
see you now.
Perfect.
Perfect. Really good. So I'm happy to talk to you today about a pretty new coating we have. It's called the Bohley MML. It's a nitride-based coating, and one that is specifically designed for applications where I would say the normal coatings, carbon-based coatings, don't work anymore. So higher temperatures, special additives in the oil. And let's go through what we have here and how this could be interesting for your application. In general, a short agenda. First of all, carbon-based coatings. It's the go-to version for tribological applications, what advantages and limitations we have, and how this could be interesting for nitride-based coatings. Then we will look specifically into the Bohley MML, what properties it has, some application results, and possibilities for combining it with carbon-based coating to get all the advantages out of the coatings. So our coatings in general are pretty thin, thin film coatings in the end. If you compare it to human hair, roughly 80 to 100 microns in diameter, a coating is somewhere in the range of 2 to 4 microns, like the black bar you see here on the hair. It represents a coating. And this has to fulfill all the requests we have. In general, it's mostly tribological topics, like the 4 dominant wear mechanisms, abrasive wear. So if you have asperities on your surface, you move it over another surface, it will plow through the material, remove, and you will end up with wear. You have a adhesive wear, so 2 materials being in contact and slided on one another, and if they are pretty common in chemical composition, they will stick to each other, rip off material which is adhering, and again, you will end up with wear of the part. So here you are removing or losing material. On the lower part here, if you're looking lower left to surface fatigue, it's more like the cyclic load on the part. So if you have something that's cycling on a surface, you will have fatigue of the material, crack propagation, and the material can break in the end. You also want to tackle this with the coating. And last but not least, tribooxidation. So 2 partners sliding on one another, and you have chemical reactions here leading mostly to oxidations, removing material, and this you also want to reduce by coating. We have here a pretty big variety of coatings where we can tailor it to your application. I want to focus today on the first 2, carbon-based and nitride-based coatings. Carbon-based is when you have a relatively low application temperature, so absolute maximum, I would say 450 degrees C. And these coatings have a lot of different characteristics with and without hydrogen, different combinations of carbon hybridizations, but all have the same main purposes: reduce wear, reduce friction, and improve endurance. And here, how do they do it? Just very briefly, such a carbon-based coating, you also know it as a DLC coating, diamond-like carbon. They are existing of SP3 and SP2 textures of the carbon. SP3 is the diamond-like structure you see here in the middle of the slide. It's the one that is pretty hard brittle, and it's making the long endurance of your part, the long lifetime because of its hardness. And you also have the SP2 structure, which is graphite. And graphite is much softer, but it's a good lubricant, so it reduces the friction. So in the end, you can see here in this triangle, you have to tune your coating specifically to your application, define the SP2 to SP3 ratio to have the best compromise between low friction, high efficiency, and long lifetime of your system. So we can do this for all our coatings and adapt it to your application. And how does it work when you have these bodies in contact? Just a brief overview here. If you have, for example, this red part here on the upper right coated, you will end up with a carbon layer on the surface. You see here on the bottom right, so this black line here is on the surface of your part. If you then bring these parts into contact, if they are sliding on one another, like you see here, it's continuous movement. Some carbon here is removed from the coating and it's transferred to your counterbody. And also the surface is been smoothened. So you have a really good contact now between two carbon layers with a low coefficient of friction. And if the carbon layer is correctly designed and if your roughness of the parts is relatively low, this will stay like this and the system will remain in a steady state. So this is actually what you want to have with these carbon-based coatings. And if you now think this is targeting the first two wear mechanisms, but if you are looking at the fatigue behavior, it also has to be tackled by the coating. And this you can do, for example, by the rest of the coating. I have two examples here of different coatings. If you start on the left, you have the substrate, which is your base material. You go with the chromium adhesion layer on top. Intermediate layer is basically the adhesion between the adhesion layer and the functional layer, because the carbon, it doesn't want to stick anywhere. That's why it has such low friction. You go here, for example, for a chromium carbide. You have the chromium to chromium contact to the substrate and adhesion layer, and the carbide to carbon adhesion to the functional layer, which means with this combination, you end up with a nice adhesion of the functional layer to the substrate. But it has one problem. If you now push your cyclic on the coating, all these layers are pretty hard and brittle, which means you have a crack propagation which is directly going through to your substrate, and you have no performance regarding the fatigue behavior. If you go for a coating, which is in our terms always having this additional star at the end, it contains a support layer, which is here a multi-layer. It's nothing more than a nanometer-wise multi-layer of different coatings, for example, chromium nitride in harder and softer versions. And if you now have a crack going through, it will be stopped at each and every of these nanometer-wise layers. Because you have a lot of these nanometer layers, you can expect an extremely long lifetime regarding fatigue behavior when you have this in your coating. And one example how this looks in a real life application is, for example, a piston pin. The smoothening you see here on the left side of the piston pin, where you have a high pressure where the load is from the cylinder. So the surface is smoothened, it's deep black, it's like you want to have it. And here, this little bit more gray area, you see still the grinding marks of the manufacturing. So this is a really good example on how these carbon-based coatings work and how they can improve lifetime and efficiency of your system. But if this isn't enough, if you have too much pressure on the system, the temperature is too high, or you have certain additives like MOTTC, this isn't working anymore. And here we have a solution, the nitride-based coatings, and specifically here, it's our Bohley 4M. And it's if you look at the image here on the lower right, it's again a chromium adhesion layer, then an interface, and then comes the MON, MO2N multi-layer structure here. So it has an extremely good coefficient of friction, so reducing wear. So coefficient of friction is comparable to a DLC coating. Multi-layer, then it has this fatigue behavior reduction, and the wear rate is extremely low of this coating. That's why we always go for a relatively low coating thickness, typically below 2 microns. The hardness of the coating is at minimum 28 gigapascal, and it's always a multi-layer. And it's a metallic coating, so you see here an image of how it looks like on your part. How does it work? It's just a combination between different compositions of molybdenum and nitride. So it's the MO2N phase of the multilayer is the more ductile one. It has a slightly decreased tribological performance and a lower temperature stability compared to the MON structure, the hexagonal structure here. This one here is more brittle. It has better tribological performance and a much higher temperature stability. So we combine these two to get the best out of two worlds, the fatigue behavior and also the reduced coefficient of friction. And how does it work, this reduced coefficient of friction? It's the last line here in this table. The molybdenum can oxidate to a phase which is MOO3. And this MOO3 is a phase which has tribological benefits. It has comparable function as the graphite in the DLC layer. So it's a lubricant in the end and reduces the friction drastically. So the idea is here to have comparable coating with higher mechanical strengths, higher chemical stability compared to the carbon-based coatings. And that we also have simulated here in tribological tests. For example, we checked it here with a DLC star in comparison to the Bohley 4M in SRV test, so reciprocal wear tester at 50 degrees C with a frequency of 10 Hertz. The load was relatively low, going to 20 newtons after the run-in. Here we had two oils, base oil with and without MOTTC additives. Counter body was a 10 mil ball, time 120 minutes, and the substrate material had a hardness of roughly 63 to 68 HRC. If you look at the coefficient of friction, we see two things. The graphs are going pretty much in a different direction here. The highest coefficient of friction, also not much higher, but it is higher, of the MON is here. It's for the MON without the MOTTC additive. And second here, this grayish graph, it's the DLC layer without this MOTTC added oil. So these two are running here pretty straight, really stable over the whole time. We see in a slightly brighter blue color the MOTTC added oil with MON still on the declining phase in the run-in. But then here on the bottom, there's a DLC layer with MOTTC, and it's drastically lower in the coefficient of friction, but really, really unstable. You have a lot of peaks here in this. And on the next images, we see why. When we look at the wear track here for the Bohley 4M without MOTTC additives, we basically see no wear on the surface. Just a bit of deposits, run-in behavior of the coating, nothing special. Same is true if you put the MOTTC here in the oil. for the DLC Star, for the carbon-based coating, we see here the intended wear track from the running in. Pretty nice, actually, as it should be. But when you look at the MODTC added oil, you see a quite severe wear of the coating. It loses basically all of the carbon content here. Its graphitization was pretty hard. That's why also the coefficient of friction dropped. But if you have now the metallic contact, you see all these spikes in the wear track, and it's nothing you want to have in your engine or in your part, because it's really uncontrollable. So if you want to use MOTTC added oil, it's not a good idea to use carbon-based coatings. And we also tested this here in real life applications for cam followers. We coated it here with the MML and also with the carbon-based coating. And what we see here in the surface on the left side, it's the MON coated part. We see basically no wear after the engine test of the coating. Black is base material ground, and that we can measure it. And the bright areas is the MML coating. So no wear was really visible. And DLC layer worked also pretty good in this application. Although this gray here, this area is some holes in the carbon where we see some wear of the DLC layer, but still the coating is intact, but the wear rate is higher compared to the MON. So conclusion here I want to draw out of this test is the MON coating has a higher hardness, higher mechanical strength, and drastically lower wear rate in comparison to other coatings, and it's also enabling here higher power densities in race application. But it comes with a big downside. It doesn't tolerate dry running. So dry running is a big problem for this coating. Here also carbon-based coatings are always better. And here we might have an interesting idea for the coating. It's the combination of the MON coating with an ACH on top. So we are combining here the best of two worlds, the molybdenum coating and the carbon coating. And the idea is if you have an engine which is running pretty well, it has a benefit of the much lower coefficient of friction of the ACH coating. But when you go into overload, need the extra safety, the extra temperature, power at some point of time, you always know you have the MON support layer underneath, which can tackle this and survive during this high power application. And we tested this also in tribological tests. We went up here to a load, not 20 like you have in the other test. We went here to 300 newtons. And after 60 minutes of testing time, we basically see no real wear of the coating. And this proves that we have an extremely good adhesion of this coating to the substrate and also to all these layers, and a really good support of the ACH layer by the high hardness of the MON base layer. And this could be an interesting step forward for high performance applications. With this, I'm ready with my presentation, and I would hand over to Emanuel.
Thank you, Doctor. All right, we see your screen, Emanuel.
Perfect. Yeah. So welcome, dear racing community from my side. My name is Emanuel Tack. I'm tribology expert at Oerlikon Balzers. And today I will guide you through the slides. Get your gearbox ready for diamond-like carbon coatings. We start with a short video.
All right, if there's audio that goes along with that, I don't think we're hearing it right now.
Well, it's not possible to select to activate the audio. Okay, so now we start with the aim, the challenges, and the tasks. So our clear aim is to reduce the lap times together with you in Motorsport. Our challenge is to increase the transmission efficiency without negatively affecting the system for sure. And our task to reach the aim is to control indirectly the temperature of the coating process for gears, and also to create a digital twin. So why do we have to reduce and control the substrate temperature of the gears during coating process? Because very often the gears are only tempered at 165 degrees Celsius. So this means 329 Fahrenheit. And you will lose substrate strength if you heat up too much. And therefore, it's really important to keep the material strength. So the digital twin, we really need to predict the reduction of power losses, to see which kind of wear mechanisms we will have, on which position we will have wear inside the gear pairing. And we can also calculate the temperature with our digital twin, which is created by the frictional power losses inside the gear. What are the benefits of the coatings for motorsports we provide? So for sure, you will have a higher reliability by our increased wear resistance of the coating. And we will have a higher performance by frictional reduction. You will have reduced costs of ownership. And our coatings with the carbon-based top layers are made for staff lubrication regime. You will have no more galling, so the cold welding between steel and steel, because we bring in the carbon to the system. You will have a higher precision of your system over lifetime because of decreased wear. Our physical coating deposition is clean, and we can reduce the coating process temperature to the customer demand. Here's an overview of the two coatings which are in focus for gears. So we have our WCC, Balinizzi, and we have Baliq Carbostar applied by S3p, which was already explained. So the WCC coating is much more ductile, it has less hardness, and the Baliq Carbostar coating combines here the best of both, as Martin already explained. So we have a high ionization of the vaporized flux, we have a dense coating, we have a smooth coating, so we need no post-treatment, there's no need for post-treatment, and we have a great adhesion of the coating to the substrate. Now we come to the different levels of testing. So for sure we can take a flat sample, apply a coating, but this is not the performance you will have in a gear. So when testing the coating performance in a gear, we test flat samples inside a dummy gear where we can variate different materials, different pretreatments like shot peening, different hardening methods, and also vibro finishing, whatever you want. So we can develop here very fast a great tribological solution for you with the right material, the right pretreatment, the right hardening, and so on, and test later on in a tribometer the system performance of our DLC coatings, what you see here in black, with your substrate. And for sure then you will see the same performance which you have here on the flat samples also in your real application. The tribometer tests we do. So here we have a staff lubrication This means we add only 5 drops of oil and create with the load round about 3 gigapascal Herzchen pressure, contact pressure. That's really a lot. So normally gears are designed for 2.5 gigapascal maximum. And these extreme tests we do here in the tribometer are about 3 gigapascal, which is high stress. And you see here that after less than 10 minutes with steel versus steel, you have galling. The coefficient of friction is increasing, and the system wears out very fast. When adding Balinese C coating, so our WCC, you will have a lower coefficient of friction and you have no galling. Same with Carbostar. But what are the differences between Balinese C and Carbostar? So the two different DLC coatings. So the Balinese C is softer, the Carbostar is harder, you know, I showed you. And here you see there is a difference in the wear resistance. So the Carbostar coating has a 7 times higher wear resistance compared to Balinese C. And this you see later on in the depths of the wear. The gears are really tricky for us to coat because we have a line of sight process during the PA-CVD coating. And what you see here is that the coating has a very great performance from the pitch to the addendum, but in the dedendum, where you have the shading effect by the neighboring gears, you will see that the coating will protect the substrate for a defined time, yes, but it will wear out faster compared to the addendum and the pitch. So you remember, without coating, we had already galling after less than 10 minutes. So this is here in the test. Now we test 4 hours, extreme testing. And the dedendum coating lasts around about, let me show you, 8 times longer compared to steel versus steel before galling starts. And on the pitch and addendum area, the coating has a much higher performance, has a higher hardness, and also more coating thickness, less shading effect from the neighboring teeth. You will have more than 28 times longer lifetime. You protect your substrate. Here you see the overview of the steel versus steel, then the steel versus Balinese C, and the steel versus Carbostar coating. Yeah, why do we need a digital twin? Everyone is talking about it, and we already have it. So in a gear, so here you see a helical spur gear. There is this line of action, so the contact between pinion and wheel. And at the end of each contact, the frictional power is increasing, the coefficient of friction is increasing, and the maximum stress is going from the substrate to the coating at the end of each contact line. Also, the temperature is increasing at the end of each contact line, and the solid body contact pressure. And by that, we know that the coating will fail at the end of each contact. When you have a system which is not suitable for the load you apply, then you will see pictures like this. At the end of each contact line, as I showed you in the simulation, you will have a high solid body contact pressure, you will have a high temperature, and the coating wears out fast if it's not the right substrate, if it's not the right coating, and if you have not the right pretreatment. So it's really important to find the right combination. And now I show you how the Carbostar coating performs versus the Balinese C coating in a digital twin of our coating system plus substrate. So we simulate the substrate plus the coating. And now you see a scratch test. I will start the animation. We increase the load from 1 until 10 Newton with a 50 micrometer radius tip. And by that, you will see when I start the video, the black crosses mean that the von Mises stress is higher than the yield strength. So that means you will have a plastic deformation. And now you already see we increase the load over time, that the Balinese C coating is at its limit. So the substrate is deforming, coating is deforming, and the coating is not anymore able to carry this load. and it will fail. When you apply the same load, I think I can show you again here. When you apply the same load with the stronger coating, the more harder coating, you see there's plastic deformation below the coating inside the substrate, but the top layer is still there. Yeah, the know-how we created is, for sure, you need a defined surface topography, or let's say a specific requirement for the surface roughness. If the surface roughness is too high, the coating growth is disturbed, and then the coating is not able to carry the load, and there's a high stress inside the coating system, only affected by the roughness, and therefore we also have to take care about pre-treatment, like vibro finishing, stream finishing, drag finishing, and so on. The coating also affects the profile of the gear. So we will have more coating signals on the top compared to the dedendum. If we heat up too much, so it depends on your tempering temperature, on your material, it can happen that the diameter of the gear is increased, what you also don't want to have. And therefore, we have to align our coating process temperature with your substrate material. If we reduce the substrate hardness too much, then of course the same coating will fail with the soft or soft-tanned material. By applying intrinsic stress, you can increase the coating performance. I'm talking about shot peening or stream finishing, where you can increase the intrinsic stress. So get your gearbox ready for diamond-like carbon coatings. Most often you will have chromium, nickel, molybdenum inside your case hardening alloy. Typical US gear steel selection you see here. And what you can apply for sure is shot peening to increase the intrinsic stress. And that means that you can increase the yield strength. And with the same load from outside, so the von Mises stress, you will have a higher performance of the system, and you have to apply more stress to deform the system. There are plenty more pre-treatment methods to increase the performance of the gears. And what we recommend is to have substrate with more than 750 hardness VCAS at the surface, more than 60 hardness rockfill, and an ideal gear flank roughness would be below 2 micro-inch, RA value, RZ value below 10 micro-inch, and RPK, so the peaks of the roughness, below 2 micro-inch. Then you will see you will have a great coating growth, you will have a great coating adhesion strength, and you will have a great coating performance at the end. We can also combine different coatings for pinion and wheel to have a kind of synergy effect. So very often you don't take the same DLC coatings for pinion and wheel. Very often one of those coatings is harder than the other. And it's not only about the hardness, it's also about the compatibility of the two DLC coatings you choose. What are our next steps? So we will receive an additional device for our tribometer. It's an oscillating tribometer, where we can test the pinion versus the wheel tooth. And we can test different pre-treatments, different hardening methods, different roughness, surface topographies, different coatings. And we can clearly show the customer which combination is suitable for this application. We also test water-based lubricants, and we already see that there is a great synergy effect between some of our coatings and the water-containing lubricant. And by that, you can increase the efficiency a lot. So there's a big jump of efficiency with taking water-based lubricants plus diamond-like carbon coatings. To summarize it up, so we have our digital twin, and by that we can check if the von Mises stress is smaller than the yield strength. Then we have a typical continuous wear, what we want to have. When the von Mises stress is higher than the yield strength, we will have excessive wear. This we have to avoid. And with our TEHL simulation tool, we can also simulate the temperature inside the contact. We can simulate the lubricant height inside the contact. We can find the location where the coating wears out and so on. Then the DLC coatings here in focus for gears is WCC, so our Balinizzi, and the Baliq Carbostar by S3p, which was explained before. We have the possibility to coat below 329 degrees Fahrenheit, and we actually develop processes which go even below that. As I mentioned, we will get this new test bench add-on feature to test two different gear teeth against each other. We can test different coatings against each other, and we already test successful water-based lubricants with our DLC coating. Yeah, that's it with our presentation. I hope you enjoyed it, and now we have time for questions. Thank you.
That was incredible presentation, gentlemen, for sure. And what a great education. I know Martin's already answered a couple of questions in the chat, but I do want to throw this one out there. He said, excellent presentation. How do your coatings behave when lubricants degrade under extreme conditions like dust, heat, water, mud, contamination in off-road racing, etc.?
Yes, thank you. Thank you for these questions. Of course, the conditions are pretty difficult, but as I've answered here in the chat, our coatings are pretty hard. And for example, the S3p coatings with Carbostar, we measured on the highest level around 40 GPa. So there must come a lot to destroy that coating. Of course, when we are talking about, I've written here, as long as no diamonds are circulating in the valve train, there will be no issue. But when there are some parts going damaged or metal, other broken things are circulating, then it will be difficult at the end. But under standard conditions, let's say everything is running, that we will survive, I think. Yes.
I did like your answer. It made me smile with as long as there are no diamonds in there. S3p, you started talking about that, Martin. Will the expansion of the SP3 portfolio continue?
Yes, yes, exactly. It will. As I mentioned in the beginning, there will come something big from us, a launch in roughly mid of November. And additionally, we develop more coatings on the S3p technology. Emanuel mentioned already that we have the Balinizzi tungsten carbide coating available on S3p. The Carbos is available. Then we have Alconos for valves, for example. Then there's, which is from coating perspective, quite old solution. This is the titanium nitride, but it's as well available as S3p. So with all the good conditions of the hardness, dense coating, and smooth coating. Yeah.
Yeah, we look forward to what you guys have to announce here in a couple of weeks for sure. As to the Balfour M, when the coating looks just like the metal, how do you keep control?
It's not an easy topic. Yes, if you have it on application, you will not see the coating on top. But if you do a grinding, like we had it in the one of the slides, you can etch the base material and you will see a contrast in color.
I like
so
that.
For quality topics or quality checks after coding, we always do this to be on the safe side.
I like that. And that was a really nice illustration in that particular slide as well. What advantage does the multi-layer structure offer over a conventional DLC star?
It's harder. So in terms of mechanical properties, it will perform a bit better. It will behave better when it's getting in hot applications or when you have certain additives in the oil. But on the contrast, it will get worse when you have no oil in the contact.
Okay. Dr. Tack, you had talked about the digital twin. How can that help you benefit from advanced gear analysis even before physical testing?
Yeah, so with the digital twin, we see if the substrate of the customer application is too soft, if the roughness is too high, if the lubricant viscosity is too low. We will see where the coating will fail and which position. What is the root cause for the failure? Is it shear stress or is it the normal load? We can calculate the film thickness between the two bodies, so between pinion and wheel, and we see if there is only the lubricant carrying the pressure or the solid body contact. We can calculate the power losses, so we can already predict the reduction in frictional power losses, and we can, by that already, take away the time you need for endless development loops. Yeah, so we can reduce that time, be more precise before coating. Yeah.
I like that. What makes coating high performance gears truly challenging?
Especially the high toothed, low modulus gears. So this means the module is the pitch circle diameter divided by the amount of teeth, so the quotient of both. And the more teeth you have, the more shading effect you have. So this means it's hard for us to come with the coating to the dedendum because we have a line of sight process. And by that, it can happen that the coating has a very good performance on the addendum and lower performance on the dedendum. And so let's say the electric vehicles, the EV gears, are quite challenging for us, but the typical combustion engine and transmission gears are, let's say, easy for us to coat when they have a modulus more than 3. It's quite easy, but below 2, it's getting a challenge. But we have also some tricks to overcome that. And of course, the tempering temperature and is also very important. We don't want to lose the tooth root bending fatigue strength, and therefore we have to reduce our coating process temperature more and more for some customers. This is also very challenging, but all in all, we find a solution at the end. Yeah.
Well, gentlemen, thank you for an amazing presentation, a great education. We look forward to what's to come here in a few weeks. As you mentioned, some folks could see at PRI, and we're just thrilled that you're here as a part of EPARTRADE, where we can do this year round.
Thank you. Thank you very much.
Thank you so much. Great presentation. So much information here to for our audience. So really well done. This webinar has been recorded. It will be posted on the EPARTRADE platform, distributed through a newsletter, a social media channel, as well as YouTube. We pushed Oerlikon's product back on the homepage of EPARTRADE. So for more information and update, please visit epartrade.com. Next webinar will be on coolant with PEEK. So again, thank you very much, and goodbye.
You're welcome. Goodbye.
Yeah, goodbye.
Bye-bye.
Hey, we want to thank you for watching. Now, be sure to like, subscribe, and click on the bell so you're always up to date with the latest racing technology, industry insights, and exclusive content from EPARTRADE. In racing, every second counts. This is EPARTRADE, the premier business-to-business platform for the performance and racing industry. We connect buyers and suppliers 24/7 worldwide. Racing never stops, neither do we. Discover cutting-edge products and services from around the globe, gaining insights from our live platform, daily newsletters, weekly webinar series, and our highly anticipated annual Race Industry Week. ePartrade.com. The racing industry, every minute, every day.
ARP, the ultimate fasteners for whatever you build. To get the best performance, always follow ARP's installation instructions included with the product. For the latest torque specs, go to ARPinstructions.com.
We're Performance Plus Global Logistics. Our team of dedicated performance industry and logistics experts get valuable cars and components to the track on time in top condition. We provide expedited logistics solutions for the performance industry using direct routes instead of deferred options, and communicate all necessary information to the appropriate resources to meet regulations and ensure a smooth transit and secure delivery, both domestically and internationally. And we exceed customer expectations by providing best-in-class service with an efficient and cost-effective system in place. Contact us today to book your next shipment.
You work as hard as your truck, and you have no time for downtime. That's why more truck owners trust Blue Def, America's #1 diesel exhaust fluid brand. Each batch is guaranteed pure, so you can avoid costly repairs caused by inferior DEF. Demand America's best for your truck. Blue Def and Blue Def Platinum. Put trust in your truck.
With roots in the Midwest that date back well before the Model T, Fifth Third Bank has a long history of serving the needs of automotive companies. While much has changed over the years, our passion for helping businesses put cars on the road and on the track has not. Today, we are more committed than ever as a member of SEMA, a founding member of PRI, and a sponsor of multiple race teams across several racing series. Where can we take your business? Fifth Third Bank.
Where will you find Farea racing components? Circle track, drag racing, and any top race shop. In every form of motorsports competition, our valves and valve train components deliver race-proven design and technology. And we've brought that same performance to our street applications as well. We're backed by 5 decades of experience, an extensive range of off-the-shelf components, and our custom valve department has the fastest turnaround times in the industry. Farea Racing Components. Stand with us or race against us.
When it comes to pushing the limits of performance, the pros know there's no room for compromise. At Crowler Cams, we don't just engineer camshafts and valve train components, we redefine what power means. Since 1955, Crowler Cams has been the name trusted by racers, engine builders, and gearheads around the globe. Whether you're building a street machine, a dragster, or a track car, Crowler Cams provides the muscle you need to dominate. And with Crowler, victory is within your reach.
At SeaTech, we're on a mission to lead the storage industry through innovative custom-built solutions that meet every challenge head-on. Designed for versatility, whether in a commercial setting or at home, we create high-quality, durable products that stand the test of time. SeaTech, engineering and innovation.